For this problem, we're going to look at question number 7 out of module 6. This problem looks at using the sum and difference identities to help us solve a problem. So this one is, we're given the sine of 15 degrees. Okay, so there's a couple of different ways that we can get the sine of 15 degrees. So if you think about it, if we're thinking about just 15 degrees, that could, remember, we want along our unit circle or out of our two special triangles, we need to either have a 30, 60, 90, or 45 degree angles to be able to utilize what we know so far in the trigonometry to help us get the exact value. Okay, so we could do it a couple of different ways. We could do 45 degrees minus 30 degrees, right? That equals 15. Or you could have said that 15 degrees is equal to 60 degrees minus 45 degrees, right? So there's many different ways that you can do this, and that is fine. I'm just trying to show you that there's multiple ways. Now, what we want to do, though, is we're looking to get 15 degrees. So let's just say we're going to take this first one here, right? So that's u minus v. So in this problem, we're asked to do the sine. So we know we need to be one of these two here because those are our sines. And if I'm doing 45 degrees minus 30 degrees, I know that I need to be using this one right here, which is my u minus v. Okay. So if u is 45 degrees and sine is, and v is 30 degrees, then I could rewrite this as sine of 15 degrees is equal to the sine of 45 degrees minus 30 degrees. Okay. And so that is then equal to sine of 45 degrees times cosine of 30 degrees minus cosine of 45 degrees times sine of 30 degrees. Okay. Now we just take our exact values. I will show you how we can do this by using the special triangles. Some of you may have just memorized the unit circle, but when dealing with a special triangle, if we're looking at a 45 degree angle, right? So our special triangle tells me that these sides are 1 and this is the square root of 2. And if I'm looking at a 30 degree triangle, this is a square root of 3 because the square root of 3 is adjacent to the 30 degrees. This is a 1 and this is a 2. Okay. So when I'm looking for the sine of 45 degrees, remember sine is my opposite over hypotenuse. So that is 1 over the square root of 2. Okay. So we have 1 over the square root of 2 times cosine is my adjacent over my hypotenuse of the 30 degrees. So that's going to be the square root of 3 over 2. Again, you could get those values off of the unit circle. Minus the cosine of 45 degrees is going to be 1 over the square root of 2 times the sine of 30 degrees, which is 1/2. Okay. So we can rationalize our denominator. If we rationalize our denominator, that is really the square root of 2 over 2. And this also is the square root of 2 over 2. And you'll see those two values, the square root of 2 over 2, on your unit circle. Okay. And so the last thing we want to do here is we can, well, not the last thing, but we want to multiply our terms here. So the square root of 2 times the square root of 3 is the square root of 6, because that's really just 2 times 3, since they are both in a square root. And then 2 times 2 is 4. Minus the square root of 2 times 1 is the square root of 2, and 2 times 2 is 4. Now, the last thing we want to do here is combine everything under one roof. So we have the square root of 6 minus the square root of 2 divided by 4. And if you think about radicals, the square root of 6, you could think of that as that's something like an x minus the square root of 2. That would be something like a y. And because they are not the exact same, we can't add, subtract, or do anything with them. And so it's similar to just having two variables like x and y here. So we can't do anything else. So this would be in the most reduced form of the answer.